So hey guys, welcome to my channel. I'm Santosh and here in my channel I discuss topics from physics and mathematics. As usual, today I'm here with one more new video for you guys, and in this video we are going to discuss NCERT numericals from the chapter Electric Charges and Fields. But before starting the discussion, I request you guys to watch the video until the very end. If you like the video, please give it a thumbs up. You can also share this video with your friends, and finally don't forget to subscribe to my channel and click on the bell icon so that you will always be notified whenever I drop a new video. So guys, let's get started. Okay guys, let us begin with question number 1. What is the force between two small charged pairs having charges 2 into 10 raised to minus 7 coulomb and 3 into 10 raised to minus 7 coulomb placed 30 centimeter apart in air? Guys, first let us see what is given and what is asked. Here we have two charged pairs and charges on these two pairs are given, and the distance between these two charges is also given. Let us denote the charges as Q1 and Q2, and let Q1 be 2 into 10 raised to minus 7 coulomb and Q2 be 3 into 10 raised to minus 7 coulomb. And R be the distance between these two pairs, and R is equal to 30 centimeters they are given, and we will convert that distance in terms of meters, and that will be 0.3 meters. And we need to find the force between these two charged pairs. Guys, before solving the question, let us first look at some of the basics that are related to this problem. Guys, we all know that when we bring two charged bodies close to one another, they exert electrostatic force on each other. In this case also, we have two charged metal pairs Q1 and Q2 separated by distance r. Q2 will experience force F21 due to Q1, and Q1 will experience force F12 due to Q2. And from Newton's third law, we know that forces always exist in pairs. And here also, F12 and F21 make action-reaction pair, which means they are equal in magnitude and opposite in direction. And the magnitude of the force is given by the Coulomb's law, which states that electrostatic force of attraction or repulsion between any two charged bodies separated by distance r is directly proportional to the product of their charges and inversely proportional to the square of distance between them. So mathematically, Coulomb's law is given as F is equal to K Q1 Q2 divided by R square. Here we have taken mod of Q1 Q2 because we need magnitude as positive value. And here the K is called as Coulomb's constant, which is equal to 1 by 4 pi epsilon naught. Epsilon naught is the permittivity of free space or air, whose value is 8.85 into 10 raised to minus 12 Coulomb square per Newton meter square. So substituting this value, you will get K as 9 into 10 raised to 9 Newton meter square per Coulomb square. But one important thing while applying the Coulomb's law is that we need to check that the charges involved are point charges or not, which means the sizes of charged bodies should be smaller than the distance between them. So in the question itself, they have given that we have two small charged pairs. So that is why we can apply the Coulomb's law in this case. Regarding the direction of force, we know that like charges repel each other and unlike charges attract each other. In this question particularly, they have given us two charges which are positive, so they repel each other. The direction of the force therefore is outwards. So Q2 will experience force in this direction, whereas Q1 will experience force in this direction. And from given, we have Q1 is equal to 2 into 10 raised to minus 7 coulomb, Q2 is equal to 3 into 10 raised to minus 7 coulomb, and R is equal to 0.3 meters. And we have Coulomb's formula to calculate the force, which is force is equal to K Q1 Q2 divided by R square. Substituting these values, you will get F is equal to 9 into 10 raised to 9 mod of 2 into 10 raised to minus 7 coulomb, 3 into 10 raised to minus 7 coulomb divided by 0.3 whole square. And now multiplying these two, will get 6 into 10 raised to minus 14, and I will write 0.3 as 3 into 10 raised to minus 1 whole square. And continuing from here, we have 9 into 10 raised to 9 into 6 into 10 raised to minus 14 divided by 3 into 10 raised to minus 1 whole square. Now if I square it, it will become 9 into 10 raised to minus 2. Now 9 and 9 gets cancelled here, and this 10 raised to minus 2 will go up and become 10 raised to 2 in the numerator. So finally we have 6 into 10 raised to 9 into 10 raised to minus 14 into 10 raised to minus plus 2. So final answer is 10 raised to 9 minus 14 plus 2. It will be 6 into 10 raised to minus 3 Newton. So therefore the force between Q1 and Q2 is equal to 6 into 10 raised to minus 3 Newton, and nature of this force is repulsive. Repulsive. Guys, now let us move to question number 2. The electrostatic force on small sphere of charge 0.4 microcoulomb due to another small sphere of charge minus 0.8 microcoulomb in air is 0.2 Newton. A. What is the distance between two spheres? B. What is the force on second sphere due to the first? Guys, again let us first see what is given and what is asked. Here we have 2 point charges Q1 and Q2 separated by some distance r, which is not given, and what is given is the magnitude of these two charges. Q1 is equal to 0.4 microcoulomb, which is equal to 4 into 10 raised to minus 7 coulomb, and Q2 is equal to minus 0.8 microcoulomb, which is equal to minus 8 into 10 raised to minus 7 coulomb. And what is also given is the force on Q1 due to Q2, the magnitude of force on Q1 due to Q2, which is equal to 0.2 Newton. Since we have one positive and one negative charge here, the nature of the electrostatic force will be attractive. So the direction of F12 will be in this direction, inwards, and the direction of F21, that is the force on Q2 due to Q1, will be in this direction. And what we need to find is the distance between these two charges, that is the distance r between these two charges. And we also need to find the force on second charge due to first charge. They have given the force on first charge due to second charge, and we need to find force on second charge due to first charge. Guys, from given we have Q1 is equal to 4 into 10 raised to minus 7 coulomb. Q2 is equal to minus 8 into 10 raised to minus 7 coulomb. And the magnitude of force on Q1 due to Q2 is given by 0.2 Newton. And we all know that from Coulomb's law we can find the electrostatic force between 2 point charges. And that formula is given by K Q1 Q2 divided by R square. In this expression, we know the value of F12, we know Q1 Q2, we don't know R. So what I will do is, I will rearrange the terms in that expression. I will take R square on this side and then take this F12 down here. So R square will be equal to K mod of Q1 Q2 divided by magnitude of F12. Now I need the value of R. For that I will take the square root of this expression. R is equal to under root K mod of Q1 Q2 divided by magnitude of F12. Now in this expression I will substitute the value of K, which is 9 into 10 raised to 9, and Q1, which is 4 into 10 raised to minus 7 coulomb, Q2, which is minus 8 into 10 raised to minus 7 coulomb, and F12, the magnitude of F12 as 0.2. Now simplifying this result, you will get the value of R as under root 0.0144, which will be equal to 0.12 meters, and in centimeters it will be 12 centimeters. So the distance between two charges is 12 centimeters, and this is the answer for the first part of this question. And now in the second part of this question, we will find out the force on Q2 due to Q1. That is, we will find out the magnitude of F21. Guys, we all know that Coulomb's law obeys the Newton's third law, which means F12 and F21, these are the action-reaction pairs. So the magnitude of F12 and F21 will be equal, and their direction is opposite. So therefore, the magnitude of F21 will be equal to 0.2 Newton, and the direction of F21 will be towards the Q1. Guys, now let us move to question number 3. Check that the ratio KE square divided by GME is dimensionless. Look up a table of physical constants and determine the value of this ratio. And what does this ratio signify? Guys, here in this question they have given us this ratio, that is KE square divided by GMP into ME, where K is the Coulomb's constant, E is the basic unit of charge, which is the magnitude of charge on proton or charge on electron. G here is the universal gravitational constant, MP is the mass of proton, and ME is the mass of electron. Guys, first we need to show that this ratio is dimensionless, and then using the values of these constants we need to calculate the value of this ratio, and finally we need to comment on the significance of this ratio. So guys, in the first part of this question, let us now show that this ratio is dimensionless. In this ratio, we have Coulomb's constant and charge in the numerator, and gravitational constant and the masses in the denominator. So just by looking at the ratio, we can tell that it has something to do with Newton's law of gravitation and Coulomb's law. So first, let us see how we can arrive at this ratio from the Newton's law of gravitation and the Coulomb's law. For that, let us consider a proton and an electron separated by distance r. So mass of proton is mp and charge on proton is plus e, and mass of electron is me and charge on electron is minus e. So using the Newton's law of gravitation, we can tell that these two, that is proton and electron, experience the force of gravitation, and that force is given by g into mp into me divided by r square. And similarly, since these two are charged particles, they will also experience the electrostatic force, that is given by Coulomb's law. Fe is equal to k mod of E into minus E divided by r square, which will become ke square divided by r square. Guys, now if you divide electric force by gravitational force, you will get Fe divided by Fg, which is equal to ke square divided by r square whole divided by g me mp divided by r square. Now here r square and r square gets cancelled, so you will be left with Fe divided by Fg, which is equal to ke square divided by g me into mp. Guys, if you see this expression, this is exactly the same ratio that is given in the question. So this expression here represents the ratio of electric force to the gravitational force between electron and a proton. Now what we want is the dimensions of this ratio. So taking dimensions on both sides, dimensions of ke square divided by g me mp is equal to dimensions of Fe divided by Fg, which is equal to dimensions of Fe divided by dimensions of Fg. Guys, if you see this ratio, we have force in the numerator as well as in the denominator. So both will have the same dimensions. So it will also have ml t raised to minus 2 and it will also have ml t raised to minus. Now cancelling these two, you can easily show that this ratio here is dimensionless. Guys, now as a second part of this problem, we will find the value of this ratio ke square divided by g me into mp. As you can see on your screen, we have values for these constants. K is equal to 9 into 10 raised to 9. E is equal to 1.6 into 10 raised to minus 19 coulomb. G is equal to 6.67 into 10 raised to minus 11 Newton meter square per kg square. Me is equal to 9.1 into 10 raised to minus 31 kg. Mp is equal to 1.67 into 10 raised to minus 27 kg. Substituting all these values in this ratio, you will get the value of this ratio as 2.2 into 10 raised to 39. Such a big value. So now this also signifies that the ratio of Fe and Fg is equal to 2.2 into 10 raised to 39. And Fe can be written as 2.2 into 10 raised to 39 into Fe. So what does this ratio signify? So basically it tells us that how strong the electric force is compared to a gravitational force. Out of four fundamental forces that we have in nature, gravity is the weakest force, whereas electrostatic force is the second strongest force after the strong nuclear force.